multiple people. Okay. Our plan with this is to glue it to the graph paper we're going to use in just a second. If you've got your own graph paper, get out a page. If not, I will gladly give you a piece. We don't want the tiny graph paper. We want the life-size graph paper. So get out a piece of graph paper if you have it. You got a graph paper? Okay, then get out a piece of graph paper. You're going to need it in addition to our thing we just cut out. My plan is when we get done, I'm going to glue. When we get done, I'm going to glue my little handout that we just made to the 2 examples we're going to do. But I'm going to wait and do the gluing after just because I don't want glue getting in my way. So I know you have glue on your desk. It's so we can glue our notes to our handouts. But I'm going to wait till, what back? The ruler? Jorgen, you want yours back, baby? Wouldn't that be nice? You might want to ask that. Go across the You play that thing? Yeah. Hey. Hey. Okay, so my plan is to glue it, but since I'm going to make 2 graphs, I'm not going to glue yet. If you want to go ahead and glue, you can. I don't really like glue. It gets in my way. Okay, so open the first flap. It says a linear inequality is similar to a linear equation. Jameson, will you fix his really quick if you didn't know how? A linear inequality is similar to a linear equation. There's nothing we have to do in that first flap. The second flap says graph the line, and when you flip inside, it explains, obviously in order to graph, we have to be in y equals mx plus b. So we need to rearrange our equation. So if I subtract x from both sides, I'm going to have negative 2y is less than negative x plus 6. You want me to zoom in there? Yes, dear.
Oh.
And then my next step would be to divide by negative 2. And remind me of what happens. We need to flip the sign. So it's going to say y is greater than, and what should I write?
Negative 1. Wait, no, positive 1/2 x?
I'm going to write positive 1/2 x, and then what else? Minus 3. Now, there are some who on their test I've noticed are having an issue with this. Yes, you get to put the x and the 2 together and it be 1/2. You forget to do 6 divided by negative 2. You forget to divide the other number. You can't forget that because then you're going to have the wrong intercept. And if you have the wrong intercept, they're going to cross at the wrong point, and then everything's just over. Okay, and then there is at least one person in the room who is making this costly mistake that I swear you should have already known how to fix, but we'll fix it now. The minus 3 is the y-intercept, so we put that on the y-axis. Do not put your first point at negative 3 on the x-axis. That is incorrect. Okay, so I go up 1 and over 2, up 1 and over 2, up 1 and over 2, and then down 1 and left 2. And I know you know how to graph, and so I'm doing it quickly. Well, most of us do. Up 1, over 2, up 1, over 2, Up 1 over 2. Up 1 over 2. Down 1 over 2. That was not as straight as it should have been, but something like that. Okay, when I connect my dots, what kind of line do I use? Okay, so we can call it dotted or dashed as long as you don't call it solid. Okay, so that is what I'm doing. And as a reminder, that's what the next slide reminds you of, solid or dotted. If we have greater than or equal to or less than or equal to, that's when we use a solid line. Otherwise, we use a dotted or a dashed line.
Wait, can we just put, like, can we do shaded or...
Oh, we're going to shade. Yeah. Where do you want to shade?
I'm talking about your arrows.
What about my arrows?
Can you, like, shade them in? Because I don't feel like dashing or anything.
I don't understand, but okay.
You don't know what I'm talking about?
No, but I'm going to leave it just like that because I like it like that. So I'm going to leave it like that. Okay, so it's greater than, where do I shade? Above. So let's shade above. Okay, based off of what I've seen from those who've already turned in their worksheet, the white worksheet that we did on Thursday and Friday, I need to remind you of this. A solution is anywhere, and I colored it brown, you can't tell, anywhere inside that region that I colored ugly. It's ugly, but it's a solution. So, for instance, 0, 0 is in that solution set. Since we use a dashed line, anything on the line is not part of the solution set. If it had been a solid line, it would be a different thing. So I know at the bottom of the white worksheet, it would give you points to check. -3, 0 in this case. No, that'd be 0, -3. 0, -3 in this case would not be part of the solution set because it's on that dashed line. Be very careful. I noticed a couple mistakes on that. Okay, and then you already know how to shade above or below. And then in case you think you're crazy, you should always use a test point. And my favorite test point is 0, 0. Yes, dear?
Okay, so about the, like, dotted and solid line, so if it's a solid line, would it still be, like, part of the...
It would be. If it was a solid line and they asked you about that point, it would be part of the solution set. Okay, so 0, 0 is part of that solution set. It was in that shaded region. So if I plug it in into our equation, 0 minus 2 times 0 is less than 6. Hey, 0 is less than 6. I'm not crazy. I know I shaded in the right region. Now, do I always do a test point? No, I don't. But when do I think it's smart to do a test point? With what Maggie was asking me about on Friday. And we're actually about to do an example of it. It's easy to see where to shade above or below when you have a tilted line like this. But when you start having a line like this, it's like which one's above, which one's below. You always use a test point now. Does everyone have this filled in? This should have been really easy if you've been here lately. It was just a refresher before we do the one new thing for the day. If you've done your stained glass project, then that was super easy. We're going to do 2 examples. I'm going to glue this later. We're going to do 2 examples on the back of our graph paper. And it says graph each system of inequalities. So what does that mean about what I'm about to write? How many equations am I going to need? I'm going to need 2. And what's nice about the 2 that I'm going to use is that they're already set up in the perfect form for graphing. So I'm going to do y greater than 2x minus 4 and y less than or equal to negative 1/3 x plus 5. If you have colors, now would be a time to have out 2 different colors at least. If you don't have colors, you can still do it with your pencil, but it's much easier to read if you use colors. Okay, my colors are kind of hard to see since we have my light on. I'm going to do my coordinate plane in one color. I'm going to go ahead and graph this line, 2x minus 4. I'm going to use my, it looks kind of brown. It is a brown. So I'm going to go down to negative 4, up 2 over 1, up 2 over 1, up 2 over 1. And then, again, you know, I'm going to use a dashed line because it wasn't equal to. Where do I shade? Above. So I'm going to go ahead and shade above. So all I've done is graph that top line. I'm going to try to color coordinate myself. Are there any questions about that? Now here's the part where we take it up one tiny, tiny notch. I'm going to graph this second equation on the same coordinate plane. So 1, 2, 3, 4, 5. And the slope is 1/3, so down 1 over 3. Down 1 over 3. Do I use a solid or a dashed line this time? I use a solid because it's less than or equal to. Okay, and then where am I supposed to shade with that pink line? Below, because it's less than or equal to. Perfect. And now it looks like we're doing complete gibberish in math class, but I swear this is what we want, and we'll talk about that in just a second.
So like the 2 lines, you get your solution. What do you do? Like, I'm confused. Why do you have 2 lines if you're just gonna like color it?
We're going to talk about that in just a sec. Do you have both your lines and all the coloring?
I have both my lines.
Do you have all your coloring? Okay, Maggie's trying to jump the gun. She doesn't understand why we're doing both these on the same, like, all it looks like is I graph this colored, graph this colored. What is that supposed to tell us anything? When we did a system of equations, we were looking for an ordered pair where the lines crossed. That's not what we're looking for with inequalities. With inequalities, it's all about shading. So the solution is where the 2 shades overlap. So what's useful when you use colors, it's kind of easy for Ms. Compton to see where my pink and brown overlaps, this region here, that is my solution set. That is my solution set. So what looks crazy that has both colors on it, this is our solution. So for instance, notice my favorite point ever, 0, 0, is inside that double colored region. That's all we have to do with inequalities. We shade both regions, and when they overlap, that's where the solution set occurs. But you know me, that's why I like to use colors. It's kind of obvious. If you're a pencil-only kind of man, then I guess you have to make that region look darker because you did it twice. It gets a little complicated. If you wanted to, because you think Ms. Compton's crazy, and that makes no sense, that seriously, that double-colored thing, that's the solution today. You could always plug in a test point, and you know I love 0, 0. You would have to plug it in both equations. It works for the top equation. You'd have to plug it in the bottom one. It works for the bottom one. So the solution set, any point you pick within it, if you plug it in both equations, both inequalities, it's going to work. Are there any questions about that? Okay, so it seems pretty easy. Unless we get confused about where to color, which is why we're going to do the next example. Our 2 equations are going to be x is greater than negative 3. And y is less than negative 1/2 x plus 4. don't forget, because I know Trey went over the bell ringers, not me, which reminds me to warn you. You know, I managed you about last week with the point slope bell ringers, so there is a point slope quiz coming sometime in the future this week. Make sure you're familiar with that. Okay, I'm going to graph the bottom one first. It seems way easier. I made them up. Put my point at 4, down 1, over 2, down 1, over 2. And I do a dash line because it was just less than. Where do I shade for the bottom equation? And that seems fine, and I'm good with that. But then the issue happens with this one, because that's what everyone's asking about on the stained glass thing. They don't know where x is greater than -3, where that happens. Where is -3? X is greater than -3. Is it here? Or is it here? It's only x. So you actually go to where -3, only x-axis, 1, 2, 3. 1, 2, 3. And you put your line there, and I'm doing a dashed line because it wasn't equal to. And then this is where we were stuck on the stained glass thing. Where do we shade? Do we shade to the left of the line or the right of the line?
Right.
You actually do shade to the right. He is correct. And if you weren't sure, you know I love me a test point. I especially love 0. When I'm thinking through, do I shade this way or do I shade that way? I plug in 0. 0 is bigger than -3. Hiram's right. I shaded to the right. Now I could also shade up here. It's everywhere. But the solution set is going to be where I've shaded twice. I've shaded both pink and brown. So this region, I don't even have to circle it. It's that big. That's where all my solutions exist. Notice 0, 0 again made this solution set. So you could always plug in 0 and make sure it all works out. Are there any questions about this? We're coloring, and where the colors overlap, that's the answer. Seriously, the coloring is your answer. The shading that you already have is the answer. I don't even need more than that. So what they'll do is what they did on that worksheet, where they ask you different points. They say, is this part of the solution set? They'll say, is 4, 2 part of the solution set? No. Is -7, 0 part of the solution set? No. Is 1, -3 part of the solution set? Yes. They'll give you checkpoints. Otherwise, seriously, that crazy looking crap is the answer. Yay! I really like solution sets of inequalities way more than systems. I bet you do too. Are there any